and recap just for memory revamping sakes. So let's start from GT209. We are doing differentiation. So I'm not going to bug you with first principle, derivation of first principle formula, but I'm just going to write out the formula and then we use the formula to work. So the formula states that for every change in y with respect to change in x, to find it, you need to limit the change in y as it is approaching 0 using f, that's function of x plus change in x minus function of x divided by change in x. So that's the formula. So given this formula now, if we are given any function or any equation, we call it equation, it is generally known as functions. If we are given a function such that y equals to 2x squared, for us to solve this, we need to say solution, okay? On our solution, we say y equals to a function of what? X. What we mean by function of x is simply this. Take for instance, whatever you are going to do depends on what I am doing, or depends on what I am going to do. And whatever you are doing now depends on what me I am doing now. It means you are depending on me, and your action depends on my action. So your action is a function of my action. When we say something is a function of another thing, what we are saying is that that particular thing that is a function of another thing depends on this other thing it is a function of. So if y is a function of x, it means that y depends on x. And if that is true, it means that the value of y depends on the value of x. So if y equals to 2x squared, it means that whatsoever y will be depends on what x will be. So take for instance, for this analogy alone, I'm going to say, let's use here for an analogy. See, this is analogy. Okay? We say for x equals to 1, y will equals to what? 2 times what? 1. Why? Because y was equals to what? 2x squared, right? So now, since we now have x to be 1, so we put that one here. So this one here represents x, because we say for x equals to what? 1. So we raise this to power what? Power 2. So that means y equals to 2 times 1 raised to power 2 is what? Still 1. So y equals to what? 2 times 1. 2 times 1 is what? 2. So we know that that is going to be the value of what? Y. So it depends on this. This is what we call functions or equation. This y is a function of what? X. So whatever x will be and whatsoever y will be, depends on what x will be. So that being certain, we know that y, for this particular equation, y is a function of what? X. And for this function of x, for this function of x, okay, we have that the function of x is what? 2x squared. So that our fx is what? 2. That's this fx. Now for us to find this, we know that if y equals to fx, then y plus change in y will equals to f x plus change in x. Now, don't get confused. Remember from the very beginning, we said that y equals to what? Function of x. So change in y will also equals to what? Function of change in x. So even if I say inverse of y equals to the inverse of the function of x, square of y equals to the square of the function of x. So whatever y you do to y, you have to do the same thing to the function, not to x alone, but to the function of x. Don't forget, the whole of this is the function of x. So it looks this marker is getting fainter with the second. Let me use this other one. So if this is true, okay, if this is true, it means that change in y equals to hey, this thing is not, it's not writing well. Sorry. Another marker? There is no other marker. Let me use the red. So if that is true, we have that for this particular part, okay, f(x) plus change in x, that's this particular one, okay, equals to, don't forget, what we are changing here now depends on this. So for this part, we are going to have 2 into, don't forget, f plus change in x will now be x plus change in x raised to power 2. We'll pause and allow you to breathe. Does any of that thing make sense? Okay, I get your confusion, but don't forget something. F with x in the bracket equals to 2 with x standing alone raised to power 2. So anything, if you change anything in this bracket, what was in this bracket before now? X. What is standing here? X. If you change anything in this bracket, you have to change x. We get up to that point. It's slowly. We are doing small. I will do another example so that it will be easier. So, for example, for now, we add x in the bracket bar, and we add x here. Now that you have changed what was in the bracket to x plus change in x, what do you do to this other side? You change the x that was standing here to x plus change in x. That means that if, analogy again, okay, this is analogy 1, so analogy 2. Analogy 2, I'm trying to explain how this, when you change this from x to this, it also affects what is going to be here. So if we have that y equals to 2x squared plus x, and we say that fx equals to what? 2x squared plus x. It means that fx plus change in x will equal to what? You change every place you have x to x plus change in x. So read them out for me. Read them out for me now. 2 what? Plus change in x raised to power 2 plus x plus change in x. The idea is simple. When what is inside the bracket changes, change everything that was here to what is inside that bracket, to that new thing in the bracket. At this place, it was x that was inside the bracket, so we have x in all this place. When you change anything that is inside the bracket, replace x with those things. So we add x here. Now we have changed it to x plus change in x, right? So you have to replace every x you see with what? This thing that is inside this bracket. And what is inside this bracket? X plus change in x. So when you see x here, you change it to what? X plus change in x. Now you've seen another x standing alone. You change it to what? X plus change in x. Okay, ask your question. Okay. Mm. This one. Okay. Uh-huh. Okay. Ye- No. If you say that, you defeat the whole purpose of mathematics. And if mathematics has a prison, they are going to lock you up. But to avoid you being locked up in the prison of mathematics, what we understand is this. This is standing alone, different from this. They are separated by what? Plus sign. So if you jack this and keep here, and you have been instructed that every place you see that there was x before, you change it to this thing that is inside this bracket, x plus change in x. It means when you see 2 here, you are just writing down this formula again. Your 2 is your 2. There was x here, right? But now there is x plus change in x. So instead of that x, what do you now write? There is your square here, and there's your square here. See your plus here, see your plus here. X is here, but you have been instructed you replace it. So you replace it with x plus change. So you are just writing the same thing that was here is what you are writing here. But the only difference is that every place you see x, you replace it with what? That's just the trick there. When you've replaced it, that's when you start solving. So this analogy too, we go back to our human being. Don't forget, this is x 2x squared, right? And we have that x plus change in x. When it comes here, what we will now have? 2. You open bracket. Since there are two things, different two things, and that's why we're opening the bracket to accommodate. So you put your x plus change in x, and then you raise power 2, which is this power 2 we have here. Now, if mathematics means anything, we know that anything raised to power 2 means that thing times that thing, right? Analogy 3. Y raised to power 2 equals to what? Y times y. 2 raised to power 2 equals to what? 2 times 2. Okay, ask your question. Eh? Again, the reason you don't bring it again is because we have not started solving for it. We are just writing out this thing here again. So the next thing we would have done if we were solving here, if this was not the analogy, what we would have done is that we'll now do 2 times this again. Then we now put our plus and bring this one down. You understand? But since this is not the guy we are solving, we are just using this one for an explanation of how to expand this and how to substitute this. That's substitute there means replace x with this. Okay? So that being aside, we now start our solving here. So we have that there is 2 here, right? We bring it down. Times. This is x plus change in x. So you put your first, it's always advisable to put a big bracket if you are going to have plenty bracket inside. So put a big bracket out. Then this your small bracket here. We'll carry this one, right? X plus change in x times x plus change in x. Then you close the big bracket. So this and this represents this two. If this was 3, it means you write this in 3 places. Okay. Thank God you understand that part. So we now say this equals to Your 2 will still be outside, okay? Nice. This is the marker. Okay. If the first thing we do is that we have x times the first x. But I don't want, since this is solving, let's do it out one after the other. So this will multiply everything that is inside here. So what we are going to have is x outside will multiply everything inside here. That's x plus change in x. Okay? Plus the change in x now. This is a second guy. Will multiply everything that is inside here. Analogy 4. The reason I'm doing an analogy is so that you get a clearer picture of what we are doing. Let's take, for example, it was A plus B that was there, and this was C plus D. I'm using this so that it should look different from that. What you do is you take the first term, that's the first variable, which is A, right? And you multiply it by everything that is inside this other side. Sorry, let me change this marker. A times everything that is here. That's C plus D. Then you put this plus down, then take B, the second term, and multiply it by everything that is inside this other side. So this times this will give you AC plus AD plus BC plus BD. That's just that. So for expand, this is called expansion. In factorization, that's about JS2. That's expansion in JS2. So you take the first term, multiply everything here, repeat the sign that is here. If it's minus, you put minus, that's in this place. If it's plus, you put plus, and then carry the second term and multiply everything that is here. So if we do this, we repeat our bracket. Hey, this one is not good. Repeat our bracket, okay? So we repeat our 2 again because we have not expanded all this inside. I'm taking them one after the other for clarity purposes. X times x is what? Square. X times change in x is what? X times change in x. Just like A times C is AC. This one is x change in x. I'm putting this change in x inside the bracket to avoid confusion. But x change in x is one term. It's a single term on its own. It's not separate. It's a single term. It's just like saying salt. Our salt is sodium chloride. They are together. It's not sodium one side, chloride one side. They are together. Or like saying 3 naira. It's 3 naira. It's not 3 different naira different. It's 3 naira gummed together. It's a single entity. So change in x times x is still the same thing as what? X change in x. And then change in x times change in x is the same thing as change in x square. Okay? And then you close your bracket. Do you have any challenge? Which side? Is it this one? The second one? Okay. This times this. Analogy 5. Analogy 5. A times B is the same thing as B times A. So A times B is what? AB. B times A is what? BA. But BA is the same thing as AB. And then in mathematics, you don't write the bigger alphabet before the smaller one. Is convention. What we mean by convention is it is a way of doing things. If you write it like this, solving some mathematics will be very confusing and will be too long, whereas you could have simplified them if you follow the convention. So for example now, you will now say x changing x times x is changing x, then you put x in brackets. You have made it to look a little bit different from this, whereas the two of them are the same thing. Remember, A times B, where this one is a A and this one is a B. You see, here it is rather B times A. That's x times change in x. Here it is change in x times x. But they are the same thing. A times b is the same thing as b times a. So if you see that a is behind, like is in front of this, all you do is make it be where it's supposed to be. That's a before b. So if you are keeping this in front, which is wrong, you should not keep this in front. Sorry. So you put this in front of this. So this times this is still this. Now change in x times change in x. Remember 3 naira times 3 naira is 3 naira square. So change in x times change in x is change in x square. You understand up to that point, right? Okay. I would appreciate if you say yes since we are doing video, so that the video people will know that you are saying yes. Okay, so we know that this also equals to 2 outside the bracket. X squared remains since there is nothing like it. But this one, they are similar. So this plus this will be 2. You know, a times a plus a is 2a. So this plus this is what? 2x change in x. What that means is, don't forget, analogy 6. If you have AB plus AB, what you are going to have is 2AB. Let me use the other analogy I love using. Your brother went outside, bought one akara and one bread. Mommy came back with one akara and one bread. All of them came back to your house. Maybe you were not feeling fine. And then they decided to just buy you something to make you feel good. And it was akara and bread mommy bought. Your brother bought akara and bread. All of them want one. The first akara and bread is called AB, akara bread, together. Brother, mommy came back, akara and bread came back. How many akara and bread do you have? 2 akara and bread. Akara and bread, mommy. Akara and bread, brother. Join them together. How many? Gari and soup, mommy. Gari and soup, brother. How many gari and soup will you have? If they were 3, how many will you have? So treat this as together, gari and soup. So plus your change in x square, close bracket. Now don't forget, everything in this bracket, because this 2 is outside, it means everything that is inside this bracket must be multiplied by what? 2. So that's for this bracket to go, right? So you have 2 times 2x, sorry, 2 times x squared is what? 2x squared. Plus 2 times 2x change in x is what? 2 times 2 is what? 4. You repeat your x change in x. And 2 times this give you 2 change in x square. Normally in mathematics, they don't put this thing in brackets. They just keep this square here. But the reason I'm putting them in brackets is to avoid confusion. This one in your textbook, you will see that it is written as x change in x. And after this solving, I'm not putting them in brackets anymore. I'm assuming that you now know. And then even if you don't want to know, you will now have to know, because that is what you will be seeing in exams and in other lecture halls. Okay, so given that we know what this is, don't forget all this solving and all this analogy. I'm using this analogy to explain this place. All this solving that we have solved so far is so that we can find this. So I'm going to clean this analogy now. You don't really need to copy down the analogy. This I'm cleaning because you don't need to copy it down. It's not that important. The most important thing is that you are understanding what we are doing, so you'll be able to solve again. After you've gotten up to this point, next thing is that you have this, right? And you have this. You know that this equals to this, right? And this equals to this. It means you have this. on top. Don't forget, that's the formula. So you now see that change in y over change in x equals to what? Lim. That's limit of x approaching 0. Fx plus f in function of x plus change in x is this, right? So you write 2x square plus what? 4x change in x plus what? 2 change in x square minus what? Fx is what? Minus what? Fx is what? 2x square. Don't ask is it, just say it is. If it is not, we will correct ourselves. Change in x still remains change in x. Okay? From this formula here, you know that this and this look the same. 2x square and 2x square is the same thing. So it means since 2x square have subtracted 2x square, it means 2x square have gone. Is it in the substitution? From this formula here. Mm-hmm. Don't forget, our f function of x plus change in x. When we finish solving it, this is what it gave to us now. So if you drag the whole of this and come here, so you are going to keep it here. See it here. You keep it. The next thing that appeared was what? Shade is a minus. Your fx, we said our y equals to fx bar, which equals to what? 2x square. So that's the 2x square we have here. Divided by this change in x. So this is a change in x. Okay. You grab number. So we now have that. Let me divide this board if this marker can divide. You know that change in y over change in x equals to the limit of what? X approaching 0. So if we do this minus this, it means this and this have gone back. So what we are left with is what? 4x change in x plus 2x square divided by what? Now, this and this have a common factor. Is it a common factor? Yeah, they have a common factor. The common factor is what? Change in x. Because we have change in x here and we have change in x here. There are two change in x here and there is one change in x here. Right? So it means that we can write this as change in y over change in x equals to the limit of change in x approaching 0, such that we have change in x outside times what? 4x. If we remove this change in x outside, we are left with only 4x. Plus, we have 2 here, right? We have removed one change in x. It's only one that is left. You agreed with me that first time now that how many change in x do we have here? 2. It's raised to power 2 bar. Now we have said, okay, this one has, this one has. It means the two of them have something in common. So see, what did we have in common? Change in x. Let's push that change in x outside. See the change in x here. It means we have removed one change in x for all of them. So since we have kept it outside, it means we have removed one from this guy. It means he does not have any other one again. So he's only left with what? 4x. See the 4x here, bah? See our plus here. We bring down our plus. What is left here? 2. But since there were two changing x, it means there is still 1 left. You have removed 1. 2 minus 1. 1. So 1 is left. So we put that one that is left. change in x, and we cover our bracket. Don't forget to make this other bracket bigger. You understand up to this point? And we divide it by what? Change in x. That allows us to say change in x cancels change in x. You understand up to that point? So if this is true, you know that change in y over change in x equals to what? The limit of change in x approaching 0, such that what this is the only thing left, 4x plus what? 2 change in x. But we know that at limit change in x approaching 0, we know that change in x equals to 0. So if change in x equals to 0, it means that change in y over change in x equals to 4x plus what? 2 times what? 0. Why? Because change in x equals to 0 at this is a condition. The reason I kept repeating this condition is so that we will not forget that this formula only works. We will not forget that this formula only works on the condition that the limit of change in x is approaching what? 0. Limit there means where change in x should stop. That's it should not pass that place. But where it should stop is approaching 0. It's as if it is almost 0. If you just move small something like this, pap, it is 0. So it means that change in x could have been equal to 0.000000001. If you want to approximate that in mathematics, we know that's 0. But we can help in small, there's other small calculation in engineering that you can help us with. So if this is this, you know that change in y over change in x equals to what? 4x. Because 2 times 0 is what? 0. And 0 plus 4x is what? 4x. So this is the final answer. Now the reason it takes as long is because I'm teaching you, but immediately you want doing it, it won't take as long. Okay, question. Ask.
Concerning the other change in x,
This one. This one.
yes.
Mm-hmm.
Why not cross? Why do you not cross the other?
Why did I not cross it here? This one. You see, it's the same reason I did not cross it here. I could have said change in x, cancel change in x, cancel change in x. But it is against mathematics if you do that. Now, we know that in mathematics, sorry, let me pause this video and check if my board will capture that slide. Okay, my board will capture it. We know in analogy, analogy, okay, we know that if there is a denominator, if we have a plus b over c, this thing means a over c plus b over c. Why does it mean that? Because we know the LCM of c and c is still c. So c divided by c is 1 times a is what? A plus c divided by c is 1 times b is b. So this is this and this is this, the same thing. So on this other side, okay, on this side here, okay, let me start from this side first. If we have something like AC plus AB divided by A, from this place, we know that it's the same thing as what? AC over A plus AB over A. So you know that for this, A can cancel A bar and A can cancel A. So what will be left is what? C plus B. That's 1. 2. If we now have A plus BC divided by C, we know that it is what? A over C plus what? BC over C. So it's only here that you can cancel, but you cannot cancel C. So this is still A over C plus what? So your C is still here. If you now go and say, since there is C up here, if you say something like A plus BC over C, you now say C cancel C, you have committed crime, because you are saying that the answer is what? A plus B, which is not true. Because from our proof here, the answer is what? A over C plus B. So that is why we need to be sure that whatsoever we are doing here, let me clean this again. You need to be sure that whatsoever we are doing here, whatsoever we are doing, or whatsoever we are cancelling, what was below here, in whatsoever we are cancelling, must be in the two of them. So for example, we have AB plus BC divided by what? B. Or let's say B square. B square. That's almost the same thing we have there. With this, we know that in AB is what? Sorry, if we expand it, we are going to have AB over B, right? Plus B square C over what? B. So B can cancel B, right? We have A left. But and then plus B cancel B, we'll be left with 1B, since that was B square. So we have B what? C. Which is what we had here. Now the B here is a change in X, and the A here is what? Before X. This cancel this, left with 4X. But when B went into this, remember, change in X is 2. So that's why we still have change in X here. And this C here is this 2 here. You understand now? So I just use two different methods. You can choose to expand it like this, so that you now cancel what is common on one side. Or you can, instead of expanding it like that, you can choose to allow it, and then you take factors, the ones that are common factors. Don't forget the common factor here was what? This. And the reason I cancelled this one was because this is a bracket. It is the same thing as saying AB over what? B. Over, sorry, let me say BC over B. Yeah. So I'm treating everything inside this bracket and become one thing, which is the C. And the change is this one. So when it is B times C over, you can cancel. But when it is B plus C over this, you should not cancel. It's only when it is times that you can cancel. But when it is plus or minus, you don't. So this is our answer. We'll pause for here, and then we'll start the video from the beginning again, so that we'll move to product rule and division rule, quotient rule. Don't worry, the video will be uploaded online, so that in case you want to copy, you copy out. But please, on the next class, I need to see that you have copied the notes. So that's all for differentiation, first rule. Any other thing apart from that is magic, and we don't do magic here.